Alright, welcome. This is 5.4 medians and altitudes. So make sure you write that at the top of your paper. Alright, so we got some vocab to go over. So first thing that you're going to do is you are going to write down the median of a triangle. So you're going to write down this sentence right here. A median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So what that means is this, though, is we have the midpoint of one side, so that splits the side into half, and to go from this midpoint to the vertex, to the opposite vertex right there, that would be called a median, right there, a median of a triangle. So when we do that to all three sides, so let's just sketch it out. Let's say that we found this one, and let's say the middle was about right there, and we found this one right here, and the middle is about right there, and then we connected it to the opposite vertice. We don't need to draw this right here. I'm just kind of showing you them. Where all three of these points come together, that's what we call the centroid of the triangle. So where the point of concurrency of the medians happens is the centroid of the triangle. So that's what we're going to write down right here. And you'll see the picture of them, way nicer drawn than I had it, and it looks just like this. So you're going to write down this box right here, and you're going to write down this sentence right here. So in a triangle, the point of concurrency of the medians is the centroid of the triangle. You don't need to write this down, but it's also the center of gravity. So it's because the point is where the triangular shape will balance. So it's like the perfect spot that you could put something through that would allow it to balance. So, alright, so when we're looking at this, the special thing about centroid of a triangle is that we see these lines right here. The special relationship is, though, that we can be able to tell the distance of this line. And the way that we can tell the distance is that we have these different formulas. So for each of them, they have 2/3. So let's look at the first one. It says DC, so this length right here is 2/3 of DJ. So we have this one, this line right here is the line that we're talking about. And to look at just this first part right here, this is going to be 2/3 of the entire line, which means that this portion right here is going to be 1/3, because 1/3 and 2/3 add together equals 3 out of 3, which is one line. So to be able to find that length of it, though, we can use this formula right here of DC, of just this line right here, would be 2/3 of DJ. And now how do we know which side is the 2/3 and so on? Well, anytime you go from the vertice of the triangle to the point of concurrency, that right there is going to be my 2/3 side. So that's how I know. From the vertice of the triangle to the point of concurrency right there would be the 2/3. So that's how I'm going to be able to find it. Okay? So we're going to use that in order to be able to do a few problems. Okay? Alright, so here we go. Here's a problem number 1. So it says, what is the length of XB? Alright, so the first thing that we need to do is we're looking at this problem, and we see that we're going from a vertice to the middle right there. So we're dealing with medians, and then where all the points meet together, that's called my centroid. Okay, so remember, we have those formulas that we just written down, and there's some specific things that we know, though. So we know that this point right here, this XA, we know that XA right here, that segment, is going to equal 2/3 of the entire segment. So the entire segment is going to equal XB. Okay? So what did the problem tell us, though? It told us that XA equals 8. So where XA is, let's plug in 8 right here equals 2/3 XB. Alright, so now we need to solve. So when we're solving, remember with fractions right here, in order to get this XB all by itself, we need to multiply by the reciprocal. Remember, the reciprocal is just taking the number and flipping it upside down. So we need to multiply this side by 2 over 3. Because then this will cancel, the 2's will cancel, and we're left with just xb, which is what we want. So we multiply one side by 3 over 2, we multiply the other side by 3 over 2. Okay, so I'm going to cross cancel. So I see both of these, I can, 2 goes into both of these. So I simplify that to 1, I simplify this to 4. Now I can multiply it out. I do 4 times 3 on the top, which is 12. 1 times 1 on the bottom, which is 1. So I get 12 over 1, which is just going to be 12 right here. So I have xb is going to equal 12. So the biggest thing with this problem, though, is knowing that from the vertice right here, that is what we're trying to find, and this whole length is going to be 2/3 of that entire length from the vertice to the middle, the median, and that's what we call our centroid problem. Okay? Alright, so the next thing that we're going to talk about is altitudes of a triangle. So I want you to write down this little paragraph right here. This one right here. So it says an altitude of a triangle is the perpendicular segment, so really important, it's perpendicular, makes 90-degree segment from the vertex of the triangle to the line containing the opposite side. An altitude of a triangle can be inside or outside of the triangle, or it can be on the side of a triangle. So really important right there. So we're going to from the vertice to the other side, and we're going to make a perpendicular segment, which means it's going to equal 90 degrees. Okay, so let's see what that would look like in our example. We don't need to write this down right here, but if we see this example, and you don't need to write this down either, but if we go from this vertice to this line segment over here, and for it to make a perpendicular angle right there, that would be my altitude right there. Now sometimes that's going to be inside, sometimes that's going to be outside. It all depends on what type of triangle it is. Okay, so let's look at the different types of triangles. So I want you to write down this right here and these 3 triangles. So it says that the lines that contain the altitudes of a triangle are concurrent at the orthocenter of the triangle. Okay, so if we were to take the altitude of each 3 of the vertices from the other side, and where those 3 lines meet together, that's called my orthocenter. Okay, so the orthocenter can be in different spots. It can be like inside the triangle, like with this acute one right here. See how each of these from the vertice to the other side make 90 degrees, and where they come together is inside. If we look at the right triangle, though, it's a little bit different. This line right here makes a perpendicular. Also going up this way right here makes a perpendicular going up this way. So this orthocenter is right there on the triangle. And if we look at an obtuse triangle is a little bit different, because in order to make a right angle and altitude right there, this goes outside of the triangle, which is fine. We can have it outside. And where these 3 are concurrent, where they come together, my orthocenter is going to be on the outside right there. Okay, so let's do a few examples seeing what that would look like. Alright, so my first problem we have right here. So for a triangle PQS, we're trying to identify, is PR a median, an altitude, or neither, and explain. Alright, so let's look at this. So if I look at QT, and I know we're not looking at that first, but if I'm going from a vertice right there to the middle, and that was a really poorly drawn thing. Let's see if I can get lighter. It's still the same. This QT, if I'm going from the vertex, or one of the vertices right there, to the middle, that would be my median. So remember, that's what median is, though. But if I'm looking at PR, though, right here, so we're trying to find PR. So I'm coming from one of the vertices right there, and it is a straight line, and it makes a 90-degree angle right there, so it's perpendicular. That right there is going to be my altitude. So that's my altitude right there. So I would say that is my altitude. That's my altitude. And how do we know that? Because it is perpendicular and it's coming from one of the vertices right there. So it comes from one of the vertices and we see it's perpendicular. How do we know that? Because we see a right angle. So remember, my altitudes can be outside the triangle, especially when it is an obtuse triangle, it will come outside of it though. Okay, so there's our first one. Let's go to our next and last one. Alright, so our last problem right here, and we got a few steps to go on it. So it says we have the vertice, we just plotted it right here. What are the coordinates of the orthocenter of triangle ABC? So remember, we are trying to find the altitudes from each of the three vertices where it makes a perpendicular angle with the other side. And then where those three are concurrent, the point of concurrency right there, that is my orthocenter. But really all I need to find is two of them because that third one is going to cross as well. So if I'm looking at this, my easiest one to be able to find is from B right here, because from B going all the way down right here, we know that this is going to make a perpendicular angle if it's straight right there. So I know that that right there is going to be 90 degrees. So that's an easy one to be able to find. Okay, but now I got to come from one of these other points and be able to find out. And I got to know like precisely how it is. Like if I were just eyeballing it, I would think that going from this point to right there, that looks like it would be a 90-degree angle. So I would assume, just kind of guessing it, I would think like 2, 4, I would think that would be my orthocenter. And this one right here would pass as well. Okay, but how, I need to be able to prove it though. Okay, so let's show how we can prove this, okay, through some mathematics. Okay, so for the first one, we have it right here, and we know that nothing changed. This is still a straight line right there, makes a 90-degree angle. Okay, so how can we find this one? Well, if we look at this line right here, we know that the slope for BC right here, and let's write the slope for BC is equals, well, what is the slope? Well, we can find these 2 points and do y2 minus y1 over x2 minus x1, or we can just look at the rise over run. So if I start here from this one, I go up 1, left 1. So my rise is going to be up 1, left 1 is going to be negative 1 over 1. Okay. Alright, so my slope is negative 1. Alright, so we think from our last unit, what do we know about perpendicular lines? Well, perpendicular lines have the opposite reciprocal slope. Alright, so that means that this negative 1 over 1, we need to flip it right here. We're going to flip that, which is still 1 over 1. It's the opposite sign. So I know that my new slope is going to be, 1. Okay, so that's my new slope. So I'm trying to find the slope that comes from here. Okay, and so if I'm looking at A right here, A is at 1, 3. So I have point 1, 3. Alright, so how can I make a line with a slope and a point? You guessed it, I have my point slope formula. So I have my y minus y1 equals m times x minus x1. And I'm going to plug these three numbers into that equation. So this is going to give me y minus 3 equals 1 times x minus 1. Okay, I distribute, I solve, we'll do it kind of quickly. Y minus 3 equals 1x minus 1. I add 3 to both sides, and y equals 1x plus 2. Alright, so if I graph this line right here, this will give me that perpendicular line that I'm wanting. So if I start at 2, that's where my y-intercept is right here. It's at 2. and my slope is 1 over 1. I go 1 over 1, or there's right there with a dot. That should go through. It looks good. 1 over 1, that goes right there. 1 over 1, 1 over 1, and I just connect these lines right here. Okay? And I see that right here where those two come together, that is 2, 4. So that is my orthocenter right there. Alright, but how could we, if we didn't have a graph and we knew that these two equations, how could we be able to solve looking at these equations? Alright, so let's do that really quickly. So we have one line right here, which is y equals x plus 2. And we have this other line right here, which is a straight vertical line. And so we know it goes through my x-axis, so I know that line right there is going to be x equals 2. So we want to know, where do these two lines cross? Okay, so how can we find that? Well, we already know x equals 2, so we know that in my coordinate x is already going to be 2. Alright, how can we find y? All we got to do is use my substitution. So I'm going to substitute a 2 in this one where x is at. So this is going to be y equals 2 plus 2. So y is going to equal 4. So I have 2, 4, and look, that's exactly what we kind of estimated it to be, and we found it using different ways. So again, when I'm solving it, I can solve it with system of equations, and I do that through substitution. So if you remember in algebra, you did substitution and elimination. It's been a little while, but I could have been able to substitute that and find out precisely where my orthocenter is. Okay. All right. Thanks for watching. We'll do some more practice in class. All right.